In this video, I'm just going to go over some quick hints and give you some guidance on directions for the week 4 activity, or whatever week it may be for your course, working with scientific notation. So the introduction is some basic problems that you would have had something similar in your lessons. So if you haven't watched the lessons, then watch those first and then go back to completing this activity. But the key things with this are, you want to make sure you read through the entire problem. You want to, for this first one, you're just going to put that in scientific notation. And remember that your numbers for the first factor have to be, it has to be 1 or bigger, up to 10, not including 10. Okay, and then it'll be times a factor of 10 to the, we'll just put question mark, however many places after the decimal, okay, is your exponent. And so if we're making this number in scientific notation, we want to force it to be a number between 1 and 10, okay, just like in your lesson. So that one's pretty straightforward, and you're putting it into scientific notation. This one here, you're actually going the other direction and putting it into standard form, okay? And make sure you include units where applicable. B, I think, is maybe a little bit tricky because we've done some unit analysis, but this one actually starts with a rate. So we want to keep it in scientific notation, 6.71 times 10 to the 8 miles. And then we're going to say per 1 hour. And then we want to multiply our unit fractions to get rid of the units that we don't want and get the ones we do want. So this is traveling in 1 minute. So hopefully you've tried this first and then you got stuck in some certain parts, or you weren't quite sure how to start. That's what this lesson is about here. This video is just a little help. So if I want to get rid of the hours, I'm going to put that up here, or I could just write hour. And then minutes is what I want to get to. But I want to have my minutes written in scientific notation. So we have 1 hour per 6.0 times 10 to the first. That will give me 60. Okay, so I just am writing it in scientific notation. And then use your exponent laws to work with that. So your units should cancel out nicely, and then you'll be left with, you'll have your number part that you can divide out times your power of 10 over here. You'll have to subtract your exponents when you're dividing the exponentials, okay? And leave your answer in scientific notation because we started with scientific notation. So in that one, it's probably best to do it, but you could write both if you're not sure. The part C here, it takes 8.3 minutes to reach the Earth from the sun. What is the distance from sun to the Earth? So in that case, we can use this same number up here to use. And we're going to do a proportion in this case. So this one, we're going to use unit analysis, just like we did in chapter 5. And then in, sorry about that, part C, we're going to do proportion, which we've probably done a little bit of. We'll do a lot more with that. So you would want to keep your units to match. So we're setting up an equation this time, and we're going to say let x equals what we're trying to find. So that's the number of miles from sun to Earth. So set up your variable, label your variable, number of miles from sun to Earth. I'm just kind of abbreviating here quickly. And then I want to have my miles. So I want the units to match and be in the same corresponding spots in the numerator and in the denominator. So then I want minutes on the bottom. So this is a very different approach. Don't mix methods. This is setting up a proportion, an equation, one fraction equal to another. And you can fill in what you're given here on this one. And then what you're trying to find here, you're going to fill in the missing part there, okay? And you're also given the 8.3 minutes you can have. So we have this answer from up here, goes in this first spot. This should go down there. X is our unknown. And then you can cross multiply to solve or clear the denominator. But remember, if A over B equals C over D, then it's true that we can multiply on the diagonal. I call that cross multiply. AD equals BC. And then you can solve for X quite nicely with that. Number 3 is very straightforward. So if that is something that you're not sure of, go back to your lessons or your textbook and you can check that out. Here's operations, same thing. Just be careful with your negatives. When you are subtracting the negative, you have to be careful how you do that. You also need to be aware that some of your answers are not going to come out in scientific notation. They may come out as a number that's like bigger than 10 or smaller than 1, and you need to make that adjustment and you need to adjust the exponent accordingly. Now that was done in your lesson, so go back there if you're not sure what I'm talking about. The application, make sure you write out your steps, and you are just going to do a division process here. We want the Neptune kilometers, okay, that it's the number of kilometers away over the number of days, and then just perform that operation there and carry down your units and write your answer in a sentence. For this summary, you are going to and I just want to say here for part 3, you do want to put everything into scientific notation first, and then you'll get an answer in scientific notation, but you can convert it back. Sorry about that. You can convert it back to standard form because our original information was given in standard form, so it would make sense to do that, but really either is fine on this one. The summary, just kind of tell me what you learned. What about the rules? What did you pick up from this? What did you like best? What did you hate? I mean, whatever you want to write, but just as if you were talking to someone in class and like kind of paired up to discuss it. Just a few sentences, and then you don't need to write a separate sheet for a summary. This is your summary that's part of your rubric anyhow in your assignment. So I hope that helps and gets you on track, and have a great day.